you want to determine how changing cutoff is going to change the true positive, true negative, false positive, or false negative rates, right? Yeah, of a diagnostic test. So basically, if you have this graph, right, and we're looking at a population, so the people in the population are on the y-axis, and then on the x-axis, we're looking at the diagnostic test itself. Good. So let's say this is the cutoff for the test. So you can draw the line, right, splitting the graph into the left and the right. So you know that what anybody that gets a particular value above the cutoff are gonna be positive. We're gonna see that a positive test result, and anybody that gets a value below the cutoff, we're gonna see that as a negative test result. Yeah, since no test is perfect, right? Most LD people are gonna have negative test results, but some LD people will also have what positive test results. So if a patient is LD, right, and they have a negative test result, that will be true negative. And the small proportion here that actually LD but had a positive test result, that will be false positive. And since the test is also not perfect, most people with the disease, right, are gonna what have a positive test result, but still a small proportion of people with the disease, right, are gonna what have a negative test result. So those are unhealthy or have the disease. So the people that are unhealthy with a positive test result, that will be true positive. Those that are unhealthy with a negative test result, that would be what false negative. Yeah, that's going to be important. So you can see, right, if this is your cutoff, all the positives are on the right side of the cutoff and all the negatives are on the left side, right, of the cutoff. So how do I relate all this to sensitivity, specificity, and then how are they going to change if there's a change in cutoff? So you should know that what sensitivity, which is the ability of the test to detect those with the disease, is basically what true positive rate. Right, that's important. And specificity, which is the ability of the test to detect those without the disease, will be true negative rate. PPV is inversely proportional to false positive, while NPV is inversely proportional to false negative. Yeah. Another way to maybe quickly remember is going to be, if you look at sensitivity here, the N in sensitivity, you can see that as NPV, and then specificity, the P in specificity, you can see that as PPV. So basically, specificity, true negative, and PPV will go in the same direction. Sensitivity, true positive, and NPV, right, will go in the same direction, right? So if I change the cutoff, so if we lower the cutoff, let's say we move the cutoff from this point A and you are moving it to point B here, right? You can see that what everything on the left will go down, true negative goes down, false negative goes down, right? If true negative goes down, specificity will go down, PPV2 will go down. All the positives on the right of the cutoff will go up, true positive goes up, false positive goes up if I lower the cutoff, right? If I increase the cutoff, I move the cutoff to C, right? Everything on the left of the new cutoff now of C will go up, right? Which means TN goes up, specificity goes up, PPV will also go up if you increase the cutoff. And if you increase the cutoff to TP goes down, if TP goes down, sensitivity to goes down, NPV2 will go down, right? So just remember, if depending on where you move, so all the positives are on the right side of the cutoff, all the negatives are on the left side of the cutoff, right? Yeah, for TN, FN, FP, TP. They are going to go in the same direction if you change the cutoff. So if you lower the cutoff, all the negatives to the left will go down, TN, FN goes down. Since TN is directly proportional to specificity, specificity will go down, and then PPV2 will go down. So you can remember that it's P in specificity, right? Yeah, also for PPV. Or if I lower the cutoff, because false positive goes up, PPV will go down, right? Because they're inversely proportional. Yeah. And on the right side of the lowered cutoff now, the new cutoff at point B, all the positives will go up, FP and TP. So if TP goes up, sensitivity will go up, NPV2 will go up, right? Or because FN goes down, if I lower the cutoff, NPV will go up since they're inversely proportional. Yep. So, and it's going to be vice versa if you increase the cutoff to point C. I hope this was helpful, right? See you soon. Thank you.